A couple months ago, Garrett, he came to me and is Garrett here or is he having a hangover? Hangover, okay.
He is having a hangover.
Okay. So he asked me and said like, oh, do you want to speak at Erlang Factory? And then he said, it would probably be interesting if you talk about Elixir adoption, like, where the adoption is, where do you think it's going to be in 2 years? And then I said, well, that's going to be a very short talk because I have no idea. And however, I do know things that are not working well, like, because users, they are coming, they're trying to learn Elixir, they're trying to learn Erlang, they're trying to get familiar with the VM, and they're stumbling into issues, right? So this talk is about that, right? About getting those things that we've seen happening a couple times and how we can ease the process. And some of those things, we already did some progress in Elixir, for example. Others we plan to, but others have no idea, right? Like what is the best way to go forward. So that's why I think it's interesting because it's a discussion we want to get started and having everyone taking part in. Yeah.
Cool. And just the public health warning part here, if parts of this talk make you feel a little bit angry, then that's good, because that's kind of what we're aiming for. So, as Francesco says, we have got this incredibly great environment, right? We can do things that nobody else can do. We've had it for at least 15, 20 years, and despite that, we're still a marginal community. We're not mainstream by any means. Now, I know a lot of people here are very happy with that. Let's keep the barbarians out. But the reality is that that's not a long-term viable solution for any community. So what we would like to do is to go through and actually have a look at why we might have this problem. And to have a look at why, well, I get a fair number of emails from people because I sit there and I was promoting Ruby for a long time. I still promote Ruby. And here I am suddenly saying, oh, Elixir is a good idea, and Erlang virtual machine is a good idea. And so people will email me about why this should be. So this is going to be one of those never do this in a presentation slides, but I'm actually going to read from a long email that I actually received because I think it's relevant. The email goes, I keep trying to apply Elixir and Erlang to problems I have, and I keep running up against issues with a terrible state of the ecosystem. Whatever the Erlang devs have done up to the last 25 years, it certainly wasn't focusing on being a citizen of the modern internet. I killed many, many hours deciphering bad documentation, fighting bugs in XML, but that's going too fast. It didn't go too fast the first time I did this. Give me a second. It's going to keep going. See, I rehearsed this. It worked. Uh-huh. All right. Let me... Blame the scheduler? Yeah, blame the intelligence of the person reading it. All right. I'm actually going to try this again because it is important. All right. Certainly wasn't focusing on being a citizen of the modern internet. I have killed many, many hours deciphering bad documentation and fighting bugs in XML and HTTP libraries over the past several weeks. Most recently, I thought I had an idea which would be a perfect application of Elixir and Erlang, then discovered its sole IMAP client library is moribund and considered unusable by the one person I could find who has tried it. Now, obviously, the libraries suck is a bad argument against the language. Ruby was in just as bad a state back in 2001 when I came to it. But there were compelling reasons to want to change that situation. In the case of Ruby, the reason was it's a joy to code. As I understand it, the compelling reason for Erlang is it has a great VM for concurrent and distributed development. But here's where I run into a problem. 5 years ago, that argument made a ton of sense. But now Clojure is a thing, and Go is a thing, Scala too for that matter. Clojure and Scala have the full Java ecosystem behind them. Go can call directly into C code, so it has the whole C, C++ ecosystem. None of them have Erlang's semantic quirks, like its obsession with arity. All of them have actor, CSP, PyCalculus concurrency abstractions baked in, just like Erlang. Given all this, It seems the sole reason to invest into Elixir over some of these other languages is the fact that the VM is simply much better than a JVM or the Go runtime. At this point, my intuition is screaming at me to ditch the Erlang VM and focus on my concurrent language energy on either Clojure or Go. I keep worrying that I'll find my way to the ecosystem issues only to find myself with a bunch of code that runs on a VM that isn't materially better than the JVM and can't be instrumented and tuned the JVM way. This is not just one person ranting. This is actually a very well-known, very smart person in the Ruby community, I admit, who actually took the trouble to come and investigate something else. And they did it in depth, and then wrote me a long email asking, okay, I want to like this, but I'm having trouble. And I hear that a lot. So what we want to do is to reconcile these two things. The fact that we're sitting on top of something which is great. We have this fantastic resource that we can use, and yet it's not perceived that way. People are not flocking to adopt the Beam environment. So a lot of you could say, well, we don't care. Right? We're happy. Right? Why do we care if other people like what we like? Because we've got what we need. It makes us, it gives us a competitive advantage even. Right? So this is not our problem, it's their problem. But our take is different. We think that we should care. We think it's actually important for us that we get other people into this environment, that we inject fresh ideas, fresh talent, and basically new bodies going forward. That way we'll get more people, more conferences, more companies, more libraries, more ideas, more technology. And eventually, if we are so damn good, then having more people using this will actually make the whole world better. So I think we do care. So I think it's a given that we have the best VM for doing the kinds of things that we're talking about. Best language? Well, I mean, you could argue that there's some room for improvement wherever you are, in any language. But we do have a great language for writing the kind of applications we write. So those aren't the issues. We don't have to sit there and rewrite Erlang or rewrite Elixir or rewrite the Beam VM in order to get people in. Instead, I think Francesco touched on this, what we need to do is to look at the barriers to entry. Right now, it just costs too much to become a member of this community. Now, I've been working with my son on his AP chemistry projects. So one of the things we've been looking at is activation energy. At this point, I wanted to do a demonstration with a small can of gasoline and a cigarette lighter, but I wasn't allowed to. Activation energy in chemistry is I'm sure you're all familiar with this, right? So you have a system that is in one state. Imagine you have, like, a can of gasoline. It's sitting there, it's exposed to oxygen. Potentially there's a lot of energy held in that can. But that energy is kind of like not used until I give it a kick. I could light it. And if I just put a small spark into it, then it can catch on fire. And once it has that initial kick of energy, then it will carry on. It's self-sustaining. But it needs to get over that hump. So what I have to do is to kick some energy into the system. Once that energy is in there, then it's stable at that new level until it runs out of gas. So how's that relevant? Well, I needed to find a way of demonstrating that to you all. And so I thought, well, what's the prototypical user I can think of to demonstrate this in our context? Who has the most expressive facial expressions I can imagine? So here we have the Keanu Reeves guide to adopting Erlang. Right, so initially, people come along, hey, this looks interesting. Right, a lot of people are saying that nowadays. Erlang's got a bit of a buzz to it, Elixir has a bit of a buzz to it. So people are coming along and saying, huh, cool, let me have a look. And so they start digging in. And it's not as easy as it might be. And so they get there, it's, yeah, I'll keep going. And this is maybe after a day, 2 days, possibly, if they have a spare time. And then eventually, they get to this phase. All right? I'm good. I'm a programmer. I know what I'm doing. I've got 10 years experience. And yet, this language is making me feel like I'm a beginner again. I don't like that. And guess what? I'm really happy doing what I was doing before. Right? And they move on. This one slide, ladies and gentlemen, demonstrates why the matrix was not written in Erlang. Had the matrix been written in Erlang, clearly Agent Smith would have won. So, we need to lower the barrier. Now, back to my son's chemistry. One of the reasons you study activation energy is because you study the process of catalysis, right? A catalyst reduces the energy required to start a reaction, sometimes to the point where the reaction will start on its own. So we're looking for a catalyst that will make it easier for people to come into our community. So what is the catalyst in this sense? You are. We are. The catalyst is to do with how we help people adopt our arcane technology. But for this to work, here's the problem. Everybody in this room has gone through that hump. Everybody in this room is saying, there's no problem. Look at me. I'm here. Right? I'm using it very happily. I don't have these issues that you're talking about. You know, you're crazy to think that there are issues. So what I'd like you to do is to try to forget that, just for a little bit. Right? I'd like you not to be Erlang experts for a little while. I'd like you to put on your outsider hat. Yeah? I want you to go back and pretend that you didn't know this stuff. Maybe pretend that you didn't have that particular gene that let you get over that hump easier than most people. Let's go back to somebody maybe like me, who just says, okay, at Erlang, I've heard a lot about it. I want to make $30 billion too, so how do I go about doing this? Oh, I know. So I'm going to go to Google, because I need to first of all learn how to write this code, and I'm going to search for something like create Erlang application. Oh, cool, right? Google is my friend. So I click. What do? I click on the first link, right? It's the official site, so it must be good. So I click on that link, and I get to that. Now, remember that I have no idea what this Erlang stuff is. So I'm looking at this. Oh, okay, so this chapter should be read in conjunction with App 4 and Application 3. So, okay, I'm game. So I click on those, but they're not hyperlinks. That's kind of unfortunate. And now I'm going to read through the rest of this. When we have written code implementing some specific functionality, we might want to make the code into an application that is a component that can be... Yeah, all right, moving on. So I hit the back button, and I say, oh, learn use some Erlang. That must be good, right? So I'm going to go and click on that. And wow, that's way prettier than the previous one. This is fantastic, right? Mandatory thing, I am not knocking this site. I'm knocking Google at this point, right? But so I look at this, and the first thing I read is, after seeing our whole application supervision tree start at one, nope, that's not going to help me, is it? All right, I still want to learn how to write an Erlang program, but back button again, right? Get down to this one. Oh, Rebar is an Erlang build tool that makes it easy to compile and test. That's what I want. I want easy, right? So I go to that page, and sure enough, easy. That's just what I want. So I read the instructions. I am not a typical programmer. I read the instructions, and I go, and I get this thing. It's trivial. It actually works, right? I git clone it, and I do what it says, type that, and it just compiled. Wow, this is easy. I like this Erlang stuff. So now I'm going to start building my first application. And again, I go on the web, and I search for things, and I discover I have to do something like this. All right, .rebar, create app, blah, blah, blah. Fine. OK, I can do that. A bit surprising about the syntax there. It's a little bit, you know, IBM 360 JCL-ish, but I mean, that's OK. You know, I can live with that. Maybe retros, whatever. Now I think to myself, OK, now let's go into my application. Oh, wait a minute. That's not what I was expecting. Oh, I'll go back. I'll read the source. Oh, it's into source. OK, that's a bit strange, but I'll go into source. And oh, damn, I've just overwritten half the source of Rebar. So I go back and I read the instructions again. I go into a separate directory. And I copy my Rebar in, and that's cool. I created an empty app. Now I compile it. Now how do I run it? I go back onto Google, and Google says that to run it, I need to type something like that, right? There's lots and lots of various crap on how I run it, but this seems to be kind of like the average of how I run it. So I run it, and this pops out. So I have 3 lines of what's going on in terms of the header. Then I have something that looks like really, really bad JSON, and then a crash dump? Wait a minute, I haven't even touched this code, and I got a crash dump. From a beginner's point of view, I want you to think about this process. I wanted to write hello world. That's all I wanted to do, is to write hello world. How far into this process am I now? 2 hours, by the time I've messed around and Googled and all this kind of stuff. And I'm faced with this. So my first question, why on God's earth do we display error messages to the console as Erlang terms? Who are we trying to impress? Right. What is the error even? Right? I'm imagining the error is init terminating in do boot. I didn't do anything called do boot. Right? So this Erlang thing must have a bug in it. That's strange. And it keeps going. Right? Where exactly is there? It's really hard to read. Right? This doesn't just affect newcomers, as I'll show you in a minute. But what we also don't get out of this is any indication whatsoever about what I should do next, apart from possibly just give up. But I don't give up. Well, maybe I do. Maybe I'm down here, and I really, really, really wanted to learn this Erlang thing. And I've got a spare morning. Maybe that's all I've got in my busy day. I've got a spare morning. So I do all this business, and I climb the curve. I put in my own energy. Right? I'm being made to feel stupid the whole time because I don't understand what's going on. It's talking to me in terms I don't understand, and clearly that's my fault because the Erlang community has a reputation of being really smart people. They get it, so it must be my fault I don't. So I'm going to get to this kind of point, and possibly, if half a day is my limit, well, I'm just going to give up and go find something else. Right? Do we care? Yes, we care, because we've just lost a smart person.
So what Dave was talking about, like all along so far, it's about the mechanics, okay? But in general, thinking in Erlang is hard to. There was very recently, there was a huge discussion in the Erlang question mailing list. And one of the very few good things that came out of it was an email from Fred Hubbard, where because he wrote Learn New from Erlang, right? And then he has good experience. Well, like people are stumbling with fun learning and so on. And then he go on and say, like, there are a bunch of things that users they're not familiar with, and they need to learn how to think in this different way. Okay, like pattern matching, recursion, higher order functions, anonymous functions. Maybe anonymous functions is going to get easier now that Java 7 has it, but who knows? Expressive-based conditionals, doing pattern matching in case, right? Single assignment, immutability, and the lack of while and for loops, which goes back to recursion and so on, right? Not using objects. You can no longer think in objects. You need to think in data structures, okay? And some of those things, right, it's part of the process, right? You need to have the activation energy to go over this stuff because it's part of writing Erlang code, it's part of writing Elixir code, right? Those things are very important to how we write code, pattern matching, recursion, and so on. But not everything fits into that list that things we could smooth the process of many things. So one that I want to use as an example is nested data structures. Okay, so imagine the following scenario, right? Like, so we can take data scenario. There's someone that is trying to go into Erlang and get into it, and they were able to pass through that initial process, right? And let's suppose he's doing a prototype for a game, okay, a game server or a game application. And part of the application, and that's what he decides to do in his prototype, is related to, like, you have rooms. Okay, you have users that are using the application, and those users can go into room and kind of exchange information between them. Okay, and when I'm in this room, I can be in the same room from different devices. Okay, so every time the user does something, it broadcasts to everyone in that room. And if I'm in that room from my phone and my computer, I need to get this message from those different devices. So I start working on this, okay, and so I figure out I need to create a small server. That's going to keep that state, and then every time there's a message, it figures out quickly to whom that message needs to go to. Okay, that's the goal, right? So so here I'm using the new Erlang map syntax. So the server state's basically going to be a map of rooms, okay? And in that map, I have a room ID, and the room ID is the key, and it points to a room, right, which is a record. And in this record, we have a little bit of information, like information about the room, and part of this information are the users in the room, okay? And that's another map where it has the user ID as key, and the values are the list of codes, and those codes identify the devices, so I know to whom the message needs to go to, and so on. If we are using a mutable language, okay, I would be able, if a user needs to join a room, I would be able to write this code, okay? I would be able to do something like, I would be able to access the whole path and then just mutate the thing at the end by adding the new codes, and it works easy and simple, right? But we are an immutable language, right? We are not giving up on that, no way, okay? So we need to do this differently, okay? And the equivalent of doing this in Erlang would be this. So what a good part of my career has been a one line of code, now has become 12 lines of code, right? I need to do step by step. So I need to match on the map on the room ID, right? And then I need to go, and then I need to destructure each part, destruct the first map with the room's ID, then destruct the record, then destruct the user's map until I finally get the codes and can put everything together, and then I do everything back, okay? At this point, you may even stop to think and say, well, actually, if something is hard, maybe it's because we don't have the correct design, right? Maybe instead I should try to denormalize my data and put everything on ETS, okay? Or I should maybe split into different processes and have them have smaller states. Right? But even answering this question is hard because this is a problem, right? We are thinking in terms of the outsider, right? This is a problem. He never had his entire life, right? He never need to think like, wait, how am I going to model my data so the updated necessary structures is going to work correctly, okay? And it doesn't need to necessarily be hard, okay? So I want to pinpoint very quickly two solutions that exist in other languages, okay? And this is not a problem to Erlang, right? It's a problem in languages where things are immutable, and that's the majority of functional programming languages. And people are going to run into this problem. They are running into this problem, right? So for example, I really like Clojure solution to this, which basically in this standard library, you have 3 functions called getting, which allows you to get some value in a very, in a nested data structure. You have a sock-in, which allows you to put a value in there. And you have update-in, which traverses the structure and calls a function so you can update the state. If we had those functions, for example, okay, we would be able to write this. We don't need no longer those 12 lines of code. We would say, okay, my state's the room. Here is how I'm going to traverse this state, right? So I need to get the room for the room ID. Then I want to get to the room users. And then I want to get to the user ID. And when I get the user ID, I have the list of code so I can just update. And this is really nice, right? And those who are familiar with Clojure feel like Clojure developers feel that this is very Clojure-esque because it goes with the Clojure way of being very pragmatic and have, it's a very simple solution and it works great, okay? But there are other solutions, for example. There are Haskell Lenses. We're not going to go into details, right? But once you learn about Haskell Lenses, you see, wait, this feels very Haskellish, right? It's like, that's exactly how I would expect a Haskell programmer to solve the problem. The problem is very well defined. And the way they think about lenses is that so they call it lenses because it's like a camera lens. It's a way you look into the data structure and you can access it and manipulate in different ways. And for those who are interested, you should, Jasper, he wrote a very kind of tutorial project that explains how lenses work in Erlang, right? And the question is, where is the Erlangish way to solve this problem? Because we feel people are constantly bumping into it, okay? So that's one of them.
And it's worth pointing out that one of the things you hear a lot is people saying, you know, Erlang is better than, or is you know, compared to whatever, is way better. And the comparison you hear typically is with Java, C++, maybe. Guys, that is not setting the bar very high. Yeah. In reality, we are, if you like, competing with languages such as Clojure. Right? That's like the new hot sauce. That's what is currently like the front runner, I guess, for the kind of applications we're writing. So we need solutions that are comparable. So let me also put on my beginner hat. I invite you all to put on your newbie hats, and we'll look at another area, OTP. All right? OTP is like, you know, it's the grail, right? It's everything. So it doesn't matter what you want to do in Erlang, right? I want to write some application. Well, clearly you need to use OTP. I need to handle events. Well, yeah, I need OTP. You know, I need to do what is best for my customer. I don't care, you need OTP, right? I need to store state. Oh, well, state, OTP, right? I need world peace. Well, clearly OTP is the only solution, right? So OTP is the hammer that does everything. Actually, it could be useful for, it doesn't matter. So OTP, yeah, it's cool. Anybody think it's perfect? It's high ceremony, very steep learning curve. It's an awful lot of duplication. If you follow the canon, and clearly you use Emacs if you follow the canon, and you bring in a gen server skeleton, you get, I think it's 126 lines of boilerplate code that doesn't do anything. You haven't added a single line of your functionality to it, 126 lines. I keep meaning to go through GitHub, find Erlang projects, and just see how many instances of that particular skeleton with nothing changed apart from some functionality added, right? How many people leave the comment blocks exactly as they are in that skeleton? So maybe we've got like a simple problem we have to solve. Common problem. At start, we need to load up a configuration file and maybe parse it, and then store the results somewhere, and then throughout the life of the application, we need to get to that configuration. So what's the solution? OTP, right? We're going to write a gen server for it. So we're going to go and get our server, and we're going to start with a skeleton. I spared you the comments, so it's down to about 40 lines of boilerplate. And at this point, we have not yet added our own application to it. All right? When we wrote the Pragmatic Programmer, one of the principles that's actually lasted over time is this principle of don't repeat yourself, dry. This kind of blows that away. Right? This is not a dry way of approaching things. But not just that. If I now add my configuration handling to this, I get really, it's hard to see. It's hard to see my configuration logic in the middle of this forest of other lines of code. Maybe you say that's a necessary evil. That's the way it works. Sorry, Dave. But if instead we looked at a language like Clojure again, it would be like this. I'll leave it to you to decide which is more attractive to someone coming in from the outside. You feeling lucky?
What? Okay, so along the same line, I want to talk about futures as well. Just kidding. So, actually, partially kidding. So, futures, I have a direction with this because I can already see some faces of despair. So, futures, they got like very popular lately, right? And then there's a lot of it coming from JavaScript, right? And in JavaScript, a future is basically this. You start a future with some computation that can possibly happen asynchronously. In JavaScript, that's likely the case. And then after that thing finishes, you need to register callbacks. Like, oh, if that thing finished well, I need to execute this on success. If it failed, I pass this on failure callback, right? And it doesn't work with Erlang, right? It's clearly, I mean, it's nonsense, right? Because first, it has this callback soup, right? Although the callbacks are not nested, right? You are thinking now about callbacks. Oh, if this works, I'm going to do this on success. And then if that thing works, I'm going to do this other thing on success, right? It doesn't work. And it's required for JavaScript because if you do things in the main block of code, it's going to block everything. But it's not a problem here, right? If a process needs to block because it's waiting for a message, Erlang is going to be running all the other processes it can in the other cores of our machine, right? We don't need to go to this style, right? There is no reason, okay? And it has a very conflated error handling, right? Oh, you need to do something on failure. You know what we do on failure? We let it crash, right? We're not worried much like, oh, on failure, we're going to do this or that, okay? So, however, we see from time to time, like people come and there are discussions in the mailing list, even their Erlang questions mailing list, like, oh, I would like a future, right? And when they say that, I don't think they want this, right? Nobody in their sane minds would ask for this explicitly. What they want is this. They simply want to start a computation, okay, and asynchronously, and later read its value back. So it's going to ask something to do some work, and then it's going to let that thing do the work while I do something else, and then I want to get the result later, okay? And the paper that mentions future for the first time, future is not related to callbacks at all, okay? There is nothing in the paper that introduces it that say about callbacks. It's like object orientation, right? Like the term that the creator of the term, like Alan Kay, he gave for object orientation is not how it's recognized in the industry at all, right? It's the same thing, right? But it came with this idea that future is about callbacks, this nasty error handling. But if we look around, okay, there are solutions to the similar problem, okay, that fits the way we do things much better. So for example, .NET has a task parallel library, okay, that has a bunch of conveniences for doing parallel work. And one of those things they have there, the basic building block is a task. So a task, you start it with an action, okay, and then you do some computation, and when you care for the result of the task, you call wait on it. Okay, so there is no callback like, oh, if it succeeds, you're going to do that. The callback's gone. And if the task fails, when you call wait, it's going to break your code too. So it feels, it's actually, the exceptions are propagating. We are not like, the errors are propagating. We're not rescuing them and try to put them under the carpet, right? So this is much better. And in fact, we write this pattern a lot in our code, right? Because a rough translation of this code would be this, okay? What we do is that we spawn a link with an action, right? And then after the action is done, we need to send a message back to the parent with the result. And then we can do some computation meanwhile. Spawn link is doing all the work, okay? And then when you're ready, when you're done, you just call receive, and you read the value, right? It's the same idea. Like I'm starting something to compute asynchronously, and then I'm going to do something meanwhile. When I care about the result, I'm going to read it, okay? And so this is very broad, right? If I was to write this code in practice, it would be a little bit, I would do a couple more things, okay? I would define two functions, a task function that receives the action I'm going to execute, and a wait function. And the task function is pretty much this. I start a reference so I can do a selective receive at the end, but Lucas told me earlier it's not going to quite work. But anyway, what we do is that I start a task and then I spawn a link. But since the action can fail, I want to catch it, so I propagate the failure on wait, and I return the reference. So it's simple still, right? And then wait is going to receive the reference, so I can receive the result of the action in when I need it, right? So task and wait. And the nice thing about this, right, is that we can implement tasks as I just showed in the task parallel library, very similar in about 15 lines of code.
Well, you can implement it in about 15 lines of code.
Yes, exactly, right? That's the thing, right? I can implement it in 15 lines of code. You can implement it in 15 lines of code, right? But if we put on our outsider hats, right, is that true? Okay? The question is, can we expect someone with 2 weeks of Erlang experience to write this code? I would say no. I would say that someone that's coming to Erlang, they would, because the language is small, like Mike was talking about it yesterday, the language is small, you can learn quickly, right? And I would expect them to read that code and have a good idea of what is happening there, okay? But I don't expect to write that code correctly, okay? Not that early, because as we said, we are still in those first weeks, we're still trying to get recursion around our head, pattern matching, right? How to think in terms of data structures, okay? So Dave and I, we say that there is an Erlang gap, okay? And the way we think about it is this, like programming languages, they have like historically had very bad tools for concurrency, okay? Like thread, locks, mutexes, okay? And Erlang, since the beginning, had those very wonderful building blocks, okay? Processes, right? Message passing, we can link processes, we can trap exits, right? This is great. It's a much higher level of abstraction to work with and very productive. But as concurrency became more and more important, what happened that those languages, they had to add very fine-grained abstractions for specific cases. Oh, you want to do some computation asynchronously, here is a task. You want to keep state, here is an agent for you, right? So they provide those high-level abstractions, very fine-grained, which are very useful. I'm not going to lie, they're very useful. They're not useful for us to write in code, right? But it's useful for lowering the barriers of the language, okay? And what happens is that, so they have those higher level abstractions, but we don't. So there's this gap, right? There is this gap in between those higher level abstractions and where we are. And for us, this gap is very easy to close, right? It's 15 lines of code. But for someone who's like just getting started, right? Someone with the outsider hat, it's a huge gap, okay? And they need to put a lot of activation energy if they want to pass it. So I think the message that we want to get out of this is that we do want to help people join our community for all sorts of reasons. So we have to make it easier to get in. We have to lower the barrier. We have to lower the activation energy required before people catch fire and get it. And I mean, it's pretty straightforward. My first Erlang program should take 10 minutes, somehow. Right? It should be obvious how to do it. I need to install Erlang, and maybe even as part of the installation process, it says, okay, so if you want to write a program,
here's something, stick into a file, type this, and it will run. Verify the installation for you, right? But not run automatically, you run it. Because that way, I get this little thrill of success that I just wrote my first Erlang program. Wow, yeah? We probably need to think very hard about how we look on the web, right? What are the likely searches that people are going to do, like create Erlang application, to start writing code? And how can we arrange things so that they get information which is suitable for a total absolute beginner to start picking up the language? Right? My very, very first Erlang program, I probably don't need to worry about supervision trees. So let's see if we can find ways of creating these tutorials and then getting them onto Google in such a way that makes sense for beginners. Error messages. I've never understood this. I edited Joe's book way back when, and I never understood it then, and I still don't understand it. Why do we display Erlang terms to the console? What possible reason is there for obscuring it that way? I mean, sure, internally pass it around like that. That's really cool. But how about we actually display them in some meaningful format? Pattern match or bad match errors. Okay, again, a really cool concept. You try and open a file, it comes back with error enoent or whatever it might be. And you think, that's really cool, until you try and answer the question, well, what file was it I couldn't open? Right? Small things like that, not a big deal. Sure, you can just put some kind of inspection in there or whatever and find it. But just small things. Think about what it's like to be a beginner and ask, could we do this better? Logging, error reporting, right? Not ideal. Is it possible we could include logger by default? Get at least slightly better. Because interestingly, as a beginner, if you go and actually try, and if you go to GitHub basho logger and actually look at the instructions, as a beginner, okay, I need better error messages because I'm a beginner. I don't understand what's going on. And I hear that this thing will give me better error messages. So I go to the page, I don't understand a single word of the installation instructions. Not a single word, including the first one, which is what, set the compiler option, and it gives me an Erlang term. A compiler option, Erlang, doesn't make sense. Right? The whole thing is just too confusing. Let's make it easier.
So it's interesting because I think like companies like Basho that are doing services, the products that people and they end up interfacing with Erlang, right? They face kind of similar problems, right? So, for example, we're going to have a talk about cuttlefish that's aimed to ease the configuration, but the same problem with Lager, right? They are using Lager because sometimes like people they're running their right clusters and then there were the error reports and they were like, wait, what is the whole thing like down? It's just an error report which tells me like, no, that thing was probably killed and someone restarted and everything's working fine, right? So Lager helps a lot with that, and it comes from this need. Even the error enoent story, I have a fun story which is, I think it was like 5 years ago or 4 years ago. My friend, he was telling me when his first experience trying to use React, so this was back then, and he copied everything in his machine, he compiled, and when he was trying to run it, he was getting bad match, error enoent, right? And that was all. Like his first time trying to run it, he never did an Erlang in his life, and then it's like error enoent, and then he tried again, no, it doesn't work, right? It for some reason he could not get it to work, so he was able to go for the stack trace, and that time we didn't even have lines in there, but you could figure out from the function, right, and the module, and then he figured out that it could not boot because there wasn't a log file. They were expecting a log file to be there, right? So it's the same thing, right? Error enoent when there is a bad match. The concept of pattern matching, just caring about the cases you want to, is very interesting. But when we run into situations, right, it doesn't give you all the information you need. Right? And with a bunch of functions, like you call them, they just give you bad arg. But wait, which argument is my bad arg? Okay, yeah. Yeah, and then, so we're talking about like nested, so some of the problems, there is no way, right? We need to have a bunch of examples and teach them and get people acquainted with thinking, recursion, getting used with pattern matching, right? But there are a bunch of problems that we can provide modern abstractions, right? So we can have Erlangish way of working with nested data structures, okay? And then when it comes to patterns regarding OTP, like agents, right, and tasks, we need to put this in the conversation, or maybe they should be included, or maybe we should start talking since the beginning how you would write those patterns with the tools we have today. And I want to make it clear that this is not, the goal of having agents or tasks is not like only to reduce the barrier of entry, right? I would definitely use patterns like that, right? And we are using in the code we write, right? Some of you probably wrote the task pattern like 10 times already in different applications, okay? And having it a name, giving it a name helps a lot in the conversation, right? Because now you can see, so in the agent server, the intent is hidden in all the code, right? But if you have things that you can say, oh, this is a task, this is an agent, it helps with the communication a lot because you look at it and say, oh, this thing is meant to keep a simple state. That's why I'm using an agent here. And you kind of have a good idea of what that code's supposed to do. And the thing is that we are talking about having those higher level fine-grained abstractions, right? And the good thing is exactly that we already have the very good foundation, right? So the problem is not like a technical problem, okay? We have the good foundation. The foundation is there. We just need to close the gap, okay? We need to lower the barriers.
So we're not knocking Erlang. We're not knocking the community. What we are saying is that it would be a really, really good idea to have people join us. Right? The world needs the technology that we have. We need to make it easier for the world to discover it. And to do that, I think it would be really helpful if every now and then we stopped being the clever, smart, billion transaction a second type people that we are, and instead put on our Keanu Reeves hat and learn to think like a newcomer. And because if we learn to think like newcomers, then I think we'll make it a whole bunch easier for newcomers to come in, and that will make it a whole lot easier for us to share the love. Thank you.